Hey guys, we are going to deal with today cases where we have solutions that don't show up on the graph. So we want to find all the solutions. And what that means is we remember that the number of solutions is equal to the degree. Right? If we have x squared, we have 2 solutions. If we have x to the 4th, we have 4 solutions. And so we know that if we have a degree 4 polynomial, then we should have 4 solutions, right? And so this one we see down here, a degree 4 polynomial, we should have 4 solutions. Whoops. Okay. So in order to kind of understand that, what I want to show you real quick is some key math ideas. And probably the 2 most important ones are this. When we solve, any one of these ideas listed here means the same thing, right? All 6 of those ideas are the same. The 2 we've been relying heavily on is this idea that we have an x-intercept of the graph, right? That idea that if when we read the graph and look at the x-axis, we can get our answers. And the one we just talked about was synthetic division. We get a remainder of 0, right? And that's, both of those ideas are going to come up here in a second, right? So we're going to look at this polynomial. X to the 4th minus x to the 3rd plus 3x squared plus minus 9x minus 54. And like always, we are going to immediately start by putting into Desmos. So I'm going to move this down, get us some space to work. And, whoops, hang on, I got things going on here. Here we go. So when we go into Desmos, what we find is that Desmos only gives us 2 of the solutions we want. So we want -2 from Desmos, and we want 3. Okay, and that's great, but we should have 4 solutions, right? That's what's up there in orange, and we're only getting 2. So what we're going to do is we're going to do some synthetic division. And from what you remember, we have talked a couple different times about how when we set up synthetic division, that kind of home row of numbers up top is just the coefficients of the polynomial. So I'm just taking what I see right here and plugging that in. Okay, the -2, of course, came from Desmos. So I'm going to do a round of synthetic division. Bring down, box times bottom, bring it up, add going down, box times bottom, bring it up, add going down, box times bottom, bring it up, add going down, box times bottom, bring it up, and we finish with a 0, which is fabulous. So -2 is a solution. And when we divide out -2, we're left with a new kind of row of numbers. And so we are going to now use those numbers with this 3. I'm not going to use the 0. I'm kind of going to stop there, and I'm going to just finish with underneath that -27. So here we go. Bring down, box times bottom, bring it up. Okay, so great news. Both of these ended in 0, which is awesome. So those 2 are for sure solutions to our polynomial. And now what we're going to do, this is where this kind of takes us to the next level. We're going to solve what is left. Okay? Here's how we're going to do it. The original polynomial was x to the 4th. After one solution was divided out, the new exponent was x to the 3rd. there were 3 solutions. After we found that one, now we're at x squared. And so this bottom row here, let's get rid of some of these arrows. This bottom row, we are going to solve x squared plus 0x plus 9 equals 0. Right? Equals 0 because that's what we started with at the beginning. Maybe to make this a little bit easier to look at, I'm just going to write as x squared plus 9. I don't really need that 0x. Subtracting 9 from both sides. X squared equals negative 9. Square root. X equals plus or minus 3i. Okay. Just a friendly little, just a little reminder. Square root of positive 9, we would write plus or minus 3. But the square root of negative 9, we write plus or minus 3i, right? That negative draws us to an I. Okay, so all of that being said, we have 4 solutions here. Okay, so the 4 solutions are negative 2, 3, 3i, and negative 3. And so we can use synthetic division and some imaginary numbers and all sorts of cool math stuff to get our final solution here. Okay, kind of a complicated process. If you look in the notebook, you'll see 2 more examples. But the key piece here, if we kind of go in order, okay, we did synthetic division as many times as we need. And then we solved what's left, right? And then at the very end, we wrote our final answer. Really hard. Let me give that one more go here. So we wrote our final answer at the very end. So kind of pieces, tie a lot of things together that we've done. I know you're going to get it figured out. I believe you. You got this.